Fernando, yeah, no. All right. So, come on. Okay. So here's a slide showing all the things that we know are good, not all the things, but many things that we know are good, and showing how they all have the same epigenetic effect, okay? So apples and broccoli and red wines. Scientists love to study red wine, a lot of NIH funding because of something called resveratrol and lycopene in there. What else? Carrots, vegetables. They all, green tea, they all block these things called DNMTs, DNA methyl transferases. So those come in and add methyl groups, okay? So these things that you consume are causing you to not turn off genes. And remember, for cancer, I told you there's that first gatekeeper hit that then causes you to have cancer. And so all of these things are preventing you from having that first hit, okay? So this is a molecular mechanism of why eating healthy is good for you outside of calories and obesity, of just these things keep your genes that prevent you from having cancer, these foods keep those on, okay? Sorry, let me move the chat so I can see. Okay. The problem is if you look at how much you would have to consume to get the effect of the studies that we're looking at in mice, it is not reasonable. So you would have to consume 795 kilograms of red wine to get the effect from resveratrol that we talk about in studies in mice. Resveratrol actually causes this red color, so there's more of it in red grapes than white grapes, or red wine than white wine. So I'm not saying that there is not an effect. We know that these have an epigenetic effect. We can measure that in humans. But when we have studies about the amount that cancer is decreased in mice, you have to look at the dosing. Okay, and so people have there's another issue of bioavailability. So resveratrol, for example, is not a very well. It's not bioavailable, so you don't ingest it and get it in your bloodstream well. So people have talked about different delivery mechanisms. So, for example, if you have ever done chewing tobacco, it creates a burning in your lip. And people used to, what did they say that was? They used to think that was fiberglass in the bird. That's an urban legend. It's actually alkaline, and so either way, it's not fiberglass, but either way, it breaks apart your tissue, and so the nicotine can go directly into your bloodstream. So people have said, well, you could put resveratrol in chewing tobacco or something. I don't think that's a worthwhile trade-off, but it would be better to get it, some other mechanism to get it at higher levels. Okay. Has anyone whatever. Marion pays for this database that a lot of times students don't know about. Have you heard of Natural Medicines, the database? No. Okay. So this is kind of like the Cochrane database for natural medicines. So if you're interested in this sort of thing, you can try it out. It used to be called Natural Standard. Now it's called Natural Medicines. And so I'm a fan of how Dr. LaFontaine talks about, various things that are pitched and sold online in these maybe Eastern medicines, and what are those? He often describes them as things that are not actually proven scientifically in a double-blinded study. So there's a lot of problems with natural compounds because you can't patent them, and so there's not an incentive to do that study. And so then this database is an effort to try to get at, okay, well, how effective are these things? And so it's kind of the best I found. So as an example, if you look up chia seeds, it gives you the background, safety, what's it used for, effectiveness, dosing and administration, toxicology, interactions with diseases, mechanism of action, and then the evidence table is probably the most likely thing you'd want to see, which is great. It has the N for a study, 27, not so good, that's not high. Is it statistically significant? Yes. I love this database because it has a quality of the study, 0 to 5, which it of course color codes. And so if you look up something like grapes that have a lot more studies, there's just tons of information with much larger N's and 5 high level quality of evidences and stuff like that. In addition, so that it's all the natural medicine and this are not me or board testable. I'm just giving you resources. A few years ago, 5 years ago now, the first reference genomes were done for epigenetics, much like we did for the human genome. We did one back then. Here, there were 111 reference epigenomes done. And so if you go to this site, which I made hyperlinkable, you can click, don't do this, just know about it if you want to do it. You can click on each part of the body, each tissue, and look at what the methylation pattern should be for histones and genes. And so in the future, if you have a patient, you get an epigenome done, you could compare it to, okay, is that normal or up or down? That's not being done right now, but in the future. So endocrine disruptors. Well, first of all, let me just show you this FYI on the right. This is showing epigenetic effects from different things like dioxin or plastics or pesticides, and showing that there's a Venn diagram overlap of these effects. So if someone is having an epigenetic effect that you want to get rid of, like let's say they have BPA in plastics, that's an endocrine disruptor or something, if they have something and you take it away, there might be something else that's having that same effect, right? So it gets very, very complicated to kind of make these super actionable. I mean, you can know certain things and be like, don't do that. And so I've highlighted some here. So we've heard about endocrine disruptors that kind of can mimic sex hormones, and they are affecting obesity, diabetes, reproduction, cancers in females, prostate cancer, thyroid. There's point cases in farm workers have been exposed to bad things like pesticides, DDT. There's common things that do stuff like high-fat diets, not having enough folate. Caloric restriction's good, folate's good. High-fat diet is bad in that they're talking about too much calories overall. And then stress, smoking, and alcohol are all bad. We're going to talk about these. Sorry, we're not going to be able to do this as a poll everywhere that I just don't want to take the time to go to. Put a yes in the comments if you want me to actually make that active so we can see. I like to show the class how they're epigenetically not doing well if they are. Oh wait, sorry, this was the poll. We can actually, I forgot, I'm good. I already set that up so we can actually go and look through those results now. Okay. All right, so in the next year, you will on average not smoke 3 packs a day. That's excellent. Okay, so these are all low. Sleep less than 7 hours a day. That's understandably high for medical students. It's bad. We'll talk about that. Drink more than 1 cup of coffee a day. Coffee's fine. We'll talk about that as long as it's not affecting your sleep. Yeah, and this one's always a little higher than I would have thought, because 8 servings of vegetables a day is actually a ton. But that's good if we want it to be higher, but okay. Say more positive things than negative comments. I would love to check yourselves on that and make sure you actually do it, but that's great. We'll talk about how words actually affect the epigenome. How do I get to the next one easily? Hold on. Can't see anything. I'll just go here. Okay, and you would like to be not bad. We have a fair amount at the ideal weight, but most of the people are overweight. Okay. What would you rank highest should be taxed? Herbicides and pesticides, number 1, then alcohol, soda, diet soda, salt, requiring shift work, and then no one wants to tax ice cream or cars. Okay, so alcohol is bad, soda is bad. Those are both good. Diet soda is interesting that came in that high. And shift work, yep, good job. Shift work should probably be higher. Okay. What would you want to subsidize? Physical therapy, behavioral therapy, fruits and vegetables, bicycles, histone deacetylase inhibitors, gastric bypass surgery, And every year, this happens every year. Everyone wants to subsidize everything. Maybe by the end of this, bypass surgery would move up. We'll see. Which laws should be allowed and not allowed bottom. Sorry. Rank the actions below if you think laws should be allowed to stop them. Right, okay. Physical abuse of 12-year-old, physical abuse of 2-year-old, neglect of 2-year-old, neglect of 12-year-old, heavy alcohol during pregnancy, 1 drink per day during pregnancy. Wow. Heavy, so that's generally thought of as okay. Well, I'll show you that probably all alcohol is bad, but 1 drink I think is, I wouldn't put it for a law, but I understand where you're coming from. Heavy drug abuse in the year before conception by mother, and then we'll talk about for the father. You got that in the right order, but the father still has an effect. And then you did not want to have an effect for 2x recommended daily caloric consumption the month before or the year before. Okay, that's all of those. Let me get that smaller. Sorry. So I went a little long or a little short before. There's some funny videos here on that guy if you want it. I normally gave that as a break. Okay. So super board testable. I am going to highlight what I want you to know on this slide. Okay. So this top part, this is the the circadian clock. How is our 24-hour cycle controlled? In the morning, you wake up, the sun comes in, it hits your eye. You'll have a lecture later, or I think I just showed you that slide. Anyway, you'll have a lecture next year about the machinery that does that from me. And that controls 10% of your proteins. Long and short, there's a hormone called melatonin, okay? And it's called the hormone of darkness. So at night, you create melatonin. So in the morning, when you wake up and the sun hits your eye, you stop creating melatonin, okay? Then I don't need you to know any of how it comes in. Just know that there's this cycle for your circadian clock involving BMAL and clock, okay? They turn on these genes. The ones you should really know are cry and period genes. Those come out, they dimerize, come back in and shut off BMAL and clock. Okay, that's probably all that would be board testable. Okay, now what I'm about to tell you is also Sage Arbor testable. There's another element that sirtuin binds. You've heard sirtuin from me, it's good. And sirtuin has an NAD plus cofactor that's needed. Okay, now NAD plus becomes NADH in a fed state. You're creating energy. So NADH can be thought of as a high energy compound. Okay. So if you have, if you're eating too much, you have a lot of NADH and you don't have NAD plus. Okay. You're removing NAD plus, so you don't have as much active sirtuin. Okay. Sirtuin's involved in circadian clock in that when it binds, it does a lot of other things, but it also turns on BMAL1 here. Okay. So just know it's affecting your circadian rhythm. Sirtuin, I think I show it here in the bottom left, is a HDAC, a histone deacetylase, okay? And clock is a histone acetylase, a hat. Now, so NAD plus you want because it activates sirtuin. Well, what affects sirtuin? Aging decreases sirtuin, aging decreases NAD plus, and food decreases NAD plus. Okay, the rest of this stuff, it can fill in the dots for you if you want. I have more in the notes, but you don't really need to know that. Okay, and so melatonin supplements we'll talk about. Those are useful. You can use those to help your sleep cycle. Sorry, I reviewed this lecture, so I hadn't given this to you yet. So here's the graph of how we're detecting that sunlight. So we have rods and cones, and the wavelength of what we're absorbing is shown here. And you see this blue line is something that people don't talk about a lot. It's a cell that has a version of rhodopsin that is kind of like a slightly non-functional version of rhodopsin. So it doesn't detect light as well, and it does that by design in an evolutionary sense. So you need a lot of light for it to be detected. And so when this iPRGC cell detects light, that is setting your circadian clock. So this is why getting bright light in the morning helps set your circadian rhythm and is good. Okay, and so here I'm showing you on the left the wavelengths of different lights. So if you have these fluorescent lights, they're emitting light at like single wavelengths. LEDs in particular are single wavelengths, whereas an old incandescent bulb is called black body radiation. It's like this gray line of sunlight, and so it covers all the colors, right? And here you see in black a fluorescent light that's only covering some. And so the different light bulbs you have, this is why fluorescent light bulbs seem harsh, because they're not covering all the lights, so they don't bounce off and show the right light. Good lights now, especially LEDs, oftentimes they'll have multiple LEDs inside, so you're getting different peaks, and then there's a coating on the outside that kind of softens that glow. But the point is, there are different lights that you can buy that will activate this IPRGC cells or not. Okay, and we'll talk about that. And sometimes you would want it active and sometimes you wouldn't, right? You don't want that active at night, like when you're watching TV, because it's going to keep you awake like it's daytime. And in the morning, you would want that if you're not exposed to light. Here is a graph showing your melatonin levels over as you age. So on the top line is when you're young, and then you go down and down. So on the top line is 20 to 35 years old, and then you go down to 36 to 50, 51 to 65, and over 65. So this is part of the reason that old people have problems sleeping, because they're not making as much melatonin. And so this is why you can actually buy melatonin and increase your sleep. Okay. You can buy melatonin over the counter. There are, it can interact with things, so you recommend talk to your doctor. Here is your sleep cycle shown according to what kind of vision you have or your type of life. So blind people actually have a very normal circadian rhythm because they can't be affected by light, which throws us off, right? By night light, by screens. And so a person that's blind, their circadian rhythms, I think actually like 25 hours. I forget if it's half an hour or an hour more, but it's longer. So their circadian rhythm will actually shift over time longer. And it should make sense kind of as a design principle that it has to be that way, because for us, if assuming you like never watch TV and we're just exposed to the sun, this would be our normal circadian rhythm. And then the next day it would go longer, but then we would be reset by the light to the same time, right? If blind people had a circadian rhythm that drifted 23 hours a day, so an hour earlier, we'd all have that problem, because it would start shifting our circadian rhythm early again before the light can reset us. So you want to evolve something that's a little long and then have some signal that can reset you, okay? Now, a normal person is much less regular than that, right? It doesn't shift over time because we get reset by the light, but we have bad habits, and so our sleep isn't as good. And then if you look at a night shift worker, they're the worst, and we'll show effects of that, but they're either working at night and then sleeping during the day, so not having light, or they're shifting when they worked, and so their sleep pattern's just very bad, and it increases their cancer risk. Blind people have a protection against breast cancer risk, for example. Normal people are whatever considered the norm, and then shift workers would be high. All right. While in the boards, you might see this as as part of the STEM, right? So like a patient comes in with insomnia from their shift work job or something, right? So this could come into play. It's much more testable for me, but the boards would have stuff like that, because it kind of starts pointing you in the diagnosis, the differential of like, okay, what's going on? Let's look at breast cancer risk. This is odds ratio again, and here are the studies if you want. And so anything over 1 is bad, right? So let's start with blindness. If you have moderate blindness, you're basically close to 1, right? If you have significant blindness, you're protected from breast cancer by about 30%, 0.66, right? 35%, 34%. And then if you have complete blindness, depending on the study, you're protected more, like 55%. Or sorry, 45% protection, 0.55-ish. Then when you go up to shift work, you have a 60% increased risk of breast cancer. Okay, 1.6 is a 60% increased risk. If you have bright light in the bedroom, you can have a 40% increased risk of breast cancer. In fact, this was a mouse study that showed increased breast cancer from light, and I think it was in the range of 40%. It was. And the amount of light that they had on for these mice was the amount of light that would be coming through like a closed door on the bottom. So it was very low. I'm surprised by that effect, and that is mice. So I put more weight on the human studies. And then also, I've seen this myself. In my house, we have a mixture of bulbs just that have burnt out. And like there's one room in particular that has some old, it must be incandescent. It's like if I go in there at night, I can't go to sleep for a while. It's too bright and it wakes me up. So these can have large effects. Insomnia, if you have insomnia once a week, your increased risk of breast cancer is 14%. 3 times a week, 40%. And if you have insomnia over 4 times a week, you're over double the risk of breast cancer. So while we want you to be doctors, we do not want you to have breast cancer. And you are doing this to yourself if you are not getting sleep. And, if you're trying, but oftentimes we're doing things, eating at night, having light at night, coffee. If you can adjust those, it's good. Okay, I see a question. Would blue light blocking glasses for night shift workers help make their sleep schedule more regular, or would it still be thrown off because they wouldn't see sunlight during the day? Pause on that. I'm going to show you a slide. So long story short, if they had blue, it depends when you are talking about them wearing that. So if they're wearing it at night, it would make them sleepier, right? So they might have a hard time at work because they would be making a little bit more melatonin, right? But it would help probably their breast cancer risk. But some of it is that basically you're deciding when your daylight hours are. I mean, probably the best thing for them would be if they had lights that made that their day. And then at night had no exposure to light. That's assuming it was constant and they ate only at night, right? And you completely shift it. I'll show you how food is also setting your circadian clock. Here's a bunch of cancers showing you that if the period genes are affected, clearly that's going to affect your circadian rhythm, breast cancer, lung cancer, pancreatic, endometrial. So for example, for what I want you to know when I show you tables like this, I want you to know the rough order. I don't need you to know the numbers, but I need you to know insomnia is the worst in this table, depending on the amount. Like insomnia once a week, not a big deal. 3 or 4 times a week, bad. Shift work is second worst, right? Blindness can protect you. And so when I put this lecture together, Epigenetics covers, almost a large portion of us. So what do we talk about and how do I present it? I tried to use high board testable yield material like circadian clock, and then rank order tables, because that's kind of how much of an effect. That's the best way I could think of to make it actionable. All right, I don't know if you've seen this magazine, the Hamisher Schlemmer magazine. It's like Sky Mall. So I just snapped a picture of it. The only thing I added was this Cyclops guy. But so they have this NASA sleep promoting light bulb. Okay. And so this is basically not having a lot of blue light. Okay. And so you can have it on and your body can still make melatonin. So this is scientifically sound, right? That would help you sleep. On the same page, they had the NASA alertness stimulating light, okay? So this is the opposite light bulb, and it is also scientifically sound just when you would use it, okay? And so, for example, so this has a lot of blue light, right? And so it shuts down your melatonin production. It's daytime. And so in old age homes, people are having problems sleeping, and then oftentimes they sleep during the day and then can't at night. So a lot of times they'll have TVs where the people are watching, they can have bulbs like this that are shining on them that are keeping them awake and keeping them from sleeping. Okay, so they're not sleeping during the day, and then when they remove that after dinner, then it's like nighttime and their melatonin starts going up. All right, any questions? All right, so what's the effect of caffeine? Most of the effects that you're used to thinking of are going to be through this A2R adenosine receptor stimulatory effects. I'm going to talk to you about how it affects through an A1R receptor, and it basically has epigenetic modifications on the circadian clock. And what is the magnitude of that? So if you, so let me back up and just talk about food in general. If you, different organs, your whole body has a circadian clock, okay? And the master regulator is light in your eye, and that creates melatonin and it goes throughout your body. Different organs, though, have control different ways. And so, for example, the liver, its circadian clock is controlled 90% by food, which makes sense because it is our energy storehouse, okay? So if, and so it sets your circadian clock in the liver as food eating in the morning, okay? And so, because you're fasting at night. Everyone, for all our evolution, has always slept, and no one's eating during sleep. So when you eat, it is signaling epigenetically, this is daytime, this is awake, right? So if you have a 16-hour fast, okay, and then you have a big meal or a meal of all probably, not like a nut, but like, let's say, I don't know, I'd guess 600-700 calories at least. 600 calories, probably even 400 calories, but let's say 600. And I don't have the data behind that, that's a guess. If you have that kind of breakfast, that sets your liver as, okay, morning time, circadian clock, go. So if you are flying to Europe and you want to fight jet lag, you can do this. If you don't eat food on the plane, wherever you get in the world, if you wait until breakfast time and you had a significant fast, 16 hours is ideal at least, and then have breakfast, it will reduce your jet lag because your body will ramp up as, okay, daytime, wake up. And you can use caffeine in the morning to set your circadian clock. There's interesting data that's just coming out about should you have the caffeine after food, maybe. So if you're gonna, it's probably better to maybe have it a little after food. That's just came out this week. Okay. Anyway, so how about caffeine versus light? If you take a double espresso 3 hours before sleep, your sleep will be delayed 40 minutes. Okay, so this is, let's say you want to go to sleep at 10. If you have a coffee after dinner at 7, you'll go to bed at 10:40. Okay, if you have bright light 3 hours before sleep, so 7 p.m. it's dark, but you're having bright light, that can delay your sleep 85 minutes. Okay, a much bigger delay. If you have light and at night and caffeine, your sleep's delayed 85 minutes. So the take home there is that light is more important than the caffeine. So if you're like, well, I'm for some reason visiting someone that has this bright bulb and we're going to hang out at 8 p.m. with the light, then sure, if they want to give you a coffee, it shouldn't hurt. So does skipping breakfast throw off your circadian rhythm too? It does. So this is a mixed bag. I get a lot. So is breakfast the most important meal of the day? The number one reason that would be true in my mind scientifically is because of this. If you could ideally pick, to me, based on the data, based on a lot of data I've read, the ideal to me would be to have a breakfast and a lunch in maybe a 6-hour window, right? You have breakfast at 8, you have lunch at noon, and then that's it. You skip dinner. That would be the idea. Now that sucks because dinner's social, right? And then, maybe the second best would be having lunch and dinner and skipping breakfast. So I think it's more important to not eat too many calories and then to probably have them in a shorter window. That's more important than making sure you have breakfast, because a lot of times when people are told you have to have breakfast, they just end up consuming more calories. They're not going to skip lunch or dinner. Okay, so if you somehow can stick to the same X number of calories, then breakfast and lunch would be better. I skip breakfast all the time, but the hours, the shortened window of eating is more important, because then if you have a shortened window of eating, you're extending your fast cycle. And that does a lot of the stuff like autophagy, although really autophagy gets up around 24 hours. So you are starting to get some of that at 16, 18 hours. Okay. What do you think about caffeine having varied effects on people? I have some friends who say it doesn't affect them. Yeah, so caffeine, you definitely get calibrated to, right? So like even individual people do. So if you have not had caffeine before, it will have a large effect. If you have it for a long time, it won't. And then if you come off it for about 2 weeks, you can feel a more of an effect when you go back on. And then beyond that, different people have different effects. But again, most of that effect is probably this A2R effect, the stimulatory effect. I don't know how much that variation follows through to the epigenetic circadian clock. And I don't know if that's known, or I know I don't know it, and I'm guessing it's not known, but I don't know. Would caffeine in the morning be considered as breaking fast? No. In most ways, no. So in the circadian clock mechanism, it does slightly help because it has epigenetic modifications. But in most ways, it does not because it doesn't have calories. Okay. And so, I'd say in the grand scheme of things. So like in fasting literature, there's a big debate over, do you have to do a water fast or can you have tea and coffee? And basically, it looks like you can have tea and coffee and that still doesn't even affect autophagy, which is like the main goal and hard to get at, the recycling of cells. Of course, that's assuming you're having black coffee. If you're having a Starbucks caramel macchiato venti, which is my drink and sucks, it's horrible for you, that's like heavy cream and sugar. So that's like having a milkshake for breakfast. Any questions? Okay. All right, so if you can't sleep well, right, and you're trying, can you just drug the person into sleep? We have these hypnotics that do make people sleep. The problem is it's not a quality sleep if you measure it. And so as you increase dosage for making people sleep, their mortality goes up. Hazard ratio is odds ratio, but for death. So, and these are very large numbers. Normally, like for breast cancer, I showed you those numbers, and they range from like 0.6 for protection to 2.2 for insomnia 4 times a week, right? So that's meaning it was I think it was 2.2 or 2.4. If it was 2.4, that would be a 140% increased risk of breast cancer, right? Well, look at this hazard ratio. Just the lowest dosage increases your risk of death 200-fold, over 200-fold, right? 100% to over 300%. And as you go up, it can go over 5, which is a 400% increase, right? 5 minus 1 is 4. And it can increase cancer too. We talked about cancer, not to as much of an effect. So these are very bad numbers. And so basically you want a quality natural sleep, okay? And to kind of posit how this lecture is based, this used to be based in year 2, and so it was in the behavioral section, and so you'll start to see more kind of psych stuff in this lecture. Okay, so again, just focus on what I am telling you to focus on here. Here is ethanol. There's 2 ways that it is hurting affecting in a harmful way epigenetics. One, it is blocking folic acid, which increases this methionine SAM that causes methylation, okay? Which I think I've shown you before. I'll have another slide. Another way is that the ethanol just being metabolized increases NADH. It converts NAD plus to NADH. Remember, NAD plus is needed for sirtuin, so the increased NADH is going to make sirtuin have less activity. And so the take home here is ethanol decreases the NAD to NADH ratio, which is bad, decreases SAM, which is bad, increases ROS, reacts to the oxygen species, which is bad, and then it blocks DNA methylation, histone acetylation, and GSH. So these are all bad. I put green here because they're, I don't know why I have green there, but anyway, this is all bad. So, and then I think I mentioned this to you that maybe not, but for a long time, like maybe 15 years, there was this recurring data coming out that alcohol, no alcohol was, fine. Having 1 drink a day was a little better then having no alcohol, and then having like 2, 3, 4, 5 got much, much worse, right? And so people started studying red wine. Is it resveratrol? Why is this good? Long story short, most of those studies, or many of the studies, had the no drinker alcohol people. They were former alcoholics, and so they had already taken a hit. And so now it looks like basically ethanol's bad and it titrates up as worse. But I would say, for your view, if you were looking at like how bad it is, 0 to 1 to 2 drinks a day, 1 drink a day for females, 2 drinks a day for male, not really a big thing. And then it starts to go up high. I have a table that kind of shows you how bad alcohol is and how far it has to go. But basically under 1 to 2 drinks a day for females and males, I wouldn't worry. But it's basically keep going up. I'm just going to skip this whole slide. You don't need to know any of this. It kind of summarizes some of that. So just save yourself time, and this was just an extra stuff. There's, stuff showing here that I've mentioned, right? Like autophagy is good. mTOR, which is the hub of detecting being in the fed state, inhibits autophagy. And so like AMPK, which is good, inhibits mTOR. You don't have to, don't worry about it. I'll skip all of this too. Just cross those 2 slides off and move on. Sorry, I lost the chat window. Hold on. Okay. So here's looking at methylation over time. And on the left, we're looking at bronchial epithelial cells in humans. And so you can see as you get older, you have decreased methylation, right? So this weird thing where when you think of old people, you might think of like slow winding down, but on a molecular level, they're having hypomethylation. So a bunch of proteins are actually turning up. And then here they have more data from mice looking at different tissues, brain, small intestine, liver, and they're all going down over time, hypomethylation. Here's a summary slide for increasing lifespan. Sirtuin is good, increasing that. What increases that? Calorie restriction. And then a bunch of bad things for ethanol. I just kind of try to make a summary slide for you. So back to the first hit thing, that for cancer, you have a gatekeeper and it has hypermethylation, and then later you have hypomethylation. We're going to look at this loss of APC, adenomatosis polyposis coli. You don't need to know that, but basically there's an activation of RAS and Wnt that we will talk about. Here's a table you don't need to know. We are just talking about APC, tumor cell invasion. Let's get rid of that. But I'm showing you that there's a bunch of other genes with hypermethylation and affecting cycles. Just we're going through APC. Whoops. Okay. So in prior years, you would have had this, but then I think a few years ago we shifted it. Have you guys gotten the Wnt pathway from Dr. LaFontaine yet? Someone type in yes or no. No. Okay. So on the right here in B is the Wnt pathway active, right? So Wnt comes in and binds frizzled, okay, this protein. There's this complex here that has DHS disheveled, okay? And it goes off and when Wnt is there and gets polyubiquitinated, you know what that is now, and gets degraded, okay? When that happens, this complex down here that has axin and APC and beta-catenin, it goes and allows beta-catenin to come in to the and kind of do inflammation type stuff, okay? So what happens when Wnt is not there? You have this thing APC, and think of it saying, I'm going to kill you, beta-catenin. All right, so when this complex is here, okay, then beta-catenin gets polyubiquitinated and broken up. So why does this matter? Beta-catenin is involved in cell growth and adhesion, so it's a proto-oncogene, so it's bad. So you want this pathway, right, where you can destroy beta-catenin, okay? And APC can block beta-catenin because APC here causes the beta-catenin to be polyubiquitinated and destroyed, okay? So APC is good, beta-catenin is bad, and so methylating APC is bad because that if you're methylating its promoter, we now know that shuts it off, and so that increases beta-catenin. Is everyone good with that? And I'm not talking down to you, but I have the recap down here. APC good, beta-catenin bad. Anyone have questions about that? I'm about to use it. All right. So Here is how that comes into play. So we have APC, and it can have hypermethylation, okay, which is bad, or it can have an hypermutation, and that causes beta-catenin activation, which activates cyclin D and c-MYC. So 80% of CRC cancers have an APC mutation, okay? And there's different types. There's type A and type C. And so here, you don't need to know this gel, but it's just showing you as you get older, you get this methylation that increases with age, okay? And so how we don't want APC to get methylated, but it is. So how can you prevent that? Well, it turns out that exercise prevents that APC methylation, hypermethylation. So again, one of these things where you're a very high level thing that you're prescribing, get exercise, is you are controlling the genetic transcription of this APC gene, which prevents cancer. And so there's this chronic inflammation that's bad and can cause cancer. And the take home, if I had to boil down like 50 exercise primary review articles, is that when you exercise, if you looked at like a genome array of inflammation, a heat map, you would see a very light increase. So exercise causes this very low level of inflammation, but what that causes is it causes you not to have massive inflammation. So exercise reduces high levels of inflammation later, okay? Okay, so again, odds ratio, how much does that matter? If you look at APC hypermethylation and you look at your type of physical activity, you don't want APC to be hypermethylated, right? So if you've exercised in the previous year, your hypermethylation odds ratio is 0.72, so you have about a 30% protection, okay? If you look at doing it the previous 5 years, you have about a 38% protection, and lifetime, you get a little bit more, 43% protection. So the take home there is, I'm trying to make this as actionable as possible. And like when you're in the clinic, I would imagine most physicians do not know this, right? This data. So if you could tell a patient, look, if you get up off your butt for 1 year, you get this biggest bang for the buck, 30% decreased risk of preserving this gene that will prevent you from having cancer or activating it. And then it's also good news that it doesn't end, right? The biggest effects are year 1, but then year 5, lifetime, you still eke out a little benefit. 5 years versus lifetime is not a big effect. I don't know. I guess that's significant. I'd have to look at the study. But anyway, long story short, exercising in the last 5 years is good. Any questions there? Okay. There are these kind of out there things that have been proven to be good now. So for example, Tai Chi has been shown to change these hypomethylation markers. And so these 4 hypomethylations and 2 hypermethylations were all in the good direction for different genes that you don't have to know. And it's the slowing range from 5 to 70%. And so my point here is that it's not, having to be Tai Chi probably that does this. I don't know if it's the breathing or this, slow exercise or whatever it is, but there are these kind of larger frame things that have been shown to have this effect, and we know a biological mechanism. All right, so on to caloric restriction, which is awesome and not as hard to do as people think. If you look in animals, okay, so this is mice. Basically, if you cut their food by 65%, that is hard to do, okay, so cut it by 2/3, they live 50% longer, okay? Now, it does not look like that will hold for humans, but if you cut the food in humans by 40%, it is looking like maybe we'll live 15% longer or something, or 20%, so you could live 15 extra years. That we don't know that. It's still being tested in primates and in humans. But across the animal kingdom, if you cut calorie restriction, it is the #1 thing that can increase lifespan by significant percentages. Okay. We're way long, so I'll skip this. You can click on this and it will take you to a video where they did a study in people where they had them work out one leg, and then I think it was a leg, and then they looked at it might have been an arm. They looked at the epigenetic change in them, in the tissues. Whoops, dang it, I clicked on it. I hope this doesn't cause an audio problem. Let me close it. I love that my hyperlinks get me. Okay. I clicked on it again. Okay. I don't think I've shown you this slide. I love this study. So gastric bypass surgery is like just one of the best proven methodologies for combating obesity. So here on these are heat maps showing an obese person pre-surgery, then a normal weight person, and the obese person after surgery. And so this is an epigenetic heat map. This is showing that epigenetically, the obese person's genome got turned to look like the normal weight person. And if you look at like where some of that was, they increased fatty acid oxidation as one example, which makes sense because they don't have calories, right? And so a high-fat diet or fasting can do that. Obesity blocks turning on the fatty acid oxidation. And so you can think of you can think of food like a drug, okay, that you're just consuming. And so when you stop consuming that drug, it stops modifying your genome. And it's hard, bypass surgery makes you do that. All right, so a summary slide for preventing cancer by physical activity. Again, you don't have to know the numbers, but I would like you to know, the highlights. So I have the cancer, the reduction in risk, and the level of evidence, number of studies. So pancreatic cancer, which sucks, you can reduce by a lot. A lung cancer, you can do a fair bit, and colon cancer has the most convincing evidence. So I don't know. That one's less important than the like because it's hard to differentiate the order. I wouldn't waste too much time on that, honestly. You can waste no time on that. Okay, so here's a study about fostering done in mice, and then we'll get to people. So if you take a mouse and remove them from the mother, they get sad, okay? And their serotonin receptors go down, okay? If you cross-foster them with and you give them a mom, the F1 generation still has serotonin response down. F2 and F3 still have serotonin response down. F4 did not. So this is an example where, and these are all male mice, so this is an animal model much closer than C. elegans showing an epigenetic effect that lasted more than the normal amount that I said, okay? One more generation more, I think. So again, in animal models, not in humans, but we'll see moving forward, to what level. Clearly the take home is that humans, it mainly affects whatever was in the mom during pregnancy. But I wouldn't be surprised if there's some signal a generation later. All right, so we're going to get more into behavioral now compared to, anyway. Also, I'll give you a quick recap so you understand what I'm talking about. There's this thing called the HPA axis, hypothalamus, pituitary, and anterior pituitary, and then adrenal cortex creates cortisol. Cortisol comes back in a negative feedback and binds a glucocorticoid receptor and prevents cortisol from kind of going off crazy, okay? So that's good that you have that feedback mechanism to control things. And so you want the glucocorticoid receptor to bind cortisol and not get too stressed out, okay? So if you take happy and sad mice, okay, there's these mice called low licking and grooming mice, so they're sad, and high licking and grooming mice that are happier, okay? If you cross foster them, where you take a high licking, let's say a low licking and grooming mouse, and you cross foster it with a high licking and grooming mother, okay, their genome, they change to be high licking and grooming. So the low licking and grooming mice have low GCR receptors, and high licking, I'll just say HLG. The high licking and grooming mice have high GCRs. So the low licking grooming mice is saved through fostering, okay? And likewise, if you take a high licking and grooming mice that has high GCR and cross foster it with a SAD parent, its GCR receptor goes down. And then if you administer HDAC inhibitors, it blocks that effect. So we know that this is happening epigenetically. And the take home would be, in people, this means if this translates to people, if you adopt a depressed child that had a poor, some problem early in life, you can salvage them. on an epigenetic level, increase their happiness, decrease their cortisol by helping that negative feedback loop. Okay? And likewise, if you have a happy child and put it in a bad situation, you're going to increase that cortisol. Okay? So low GCR receptors end up in increased suicide. So there's a lot of, public policy ramifications here. All right. If you take a mouse and you do fear conditioning, which is basically electrocuting them, or this little cage can shock them, that decreases their BDNF. And that same thing happens if you deprive them of other mice for a week. They like to be in a social atmosphere, right? And this happens via DNA methylation in the promoter region. Okay. BDNF, brain-derived neurotropic factor, increases neurogenesis, learning, and memory. So it's this good thing, okay? If you exercise, you increase BDNF up to 3-fold, okay? And incidentally, cocaine increases acetylation of the BDNF gene histones, increasing BDNF too. So having a positive effect in that regard. All right. Can we treat people with some of this? So if you are stressed, you have this chromatin remodeling, which decreases histone acetylation at the BDNF gene in the hippocampus. And there are tricyclics, trophinyl, which reverse that process by histone acetylation. Okay? So we're starting to have drugs where if you don't have good parenting, you could medicinally try to have that effect, which is great. On to some of the, things we can't do in the lab again. After 9/11, they went back and looked at pregnant women that were in the towers, and 38 of 200 had PTSD, and they had, I thought that was increased cortisol. They had a change in cortisol from normal. There were 16 genes expressed differently, and it was worse in the third trimester. Just know that trauma can affect that. And so I used to give this lecture with a psychologist, and so there's this 5-finger rule of parenting where you just kind of do these general good things that causes a child to be happy, and it has these epigenetic effects we know now. So hold them, something tactily, look in their eyes, visual, talk to them, auditory, soothe them, and laugh and smile. And And so this is kind of like this lecture is the biggest example I can give of where, sticks and stones may break my bones, but words will never hurt me. Well, words epigenetically hurt you and shut genes on and off. Okay. All right. I will not do this poll everywhere. There's a link here to, you can look at these ACEs, Advanced Adverse Childhood Experiences. And so this is kind of like a quiz where, let me know if you have a question. I heard something. Will this happen at slow developmental age? SGA, it will what happen? I don't know what you're talking about. Are you talking about the GCR receptor? The adoption stuff. That is happening earlier. I don't know about slow at SGA. I assume it is. In fact, it might happen at all ages, right? I mean, it could be that adults have this effect. That's very likely. I don't know that data. I know that this is talking about from basically birth children and mice. Okay. So anyway, this is like a checklist where you can say, oh man, hold on. I have a low battery. Let me see if I'm going to make it. Okay. Talk amongst yourselves for 60 seconds while I get a charger. All right, we're back. So, all right. So anyway, you can have this checklist to figure out how bad people are or how likely the child is to have these effects. And so if you look at these ACEs, basically, as you get more ACEs racked up, bad things happen. So you could target them, let me go back. So just to kind of give you an idea, physical abuse, sexual abuse, emotional neglect, substance abuse. And if you look at the magnitude of that, you can start having upwards of 20% increased chance of separation, divorce, drinking problems, emotional abuse. So none of this is rocket science, but you can start to tick off, well, we have 6 ACEs. Let's try to get this down to 3 and target these 3 realms of your life. And the more, so here we're looking at the number of ACEs and how bad things are going. So for depression, you see that this is percent, like having 1 or 2 ACEs isn't horrible, 10 or 20% increase. But if you have 5 ACEs, you have a 36% increased chance of depression. Anxiety and depression are kind of the biggest hits. More about ACEs, nothing new testable here. All right, that is it. Sorry, I did not need to get that charger. Are there any questions? Just some extra bonus stuff I forgot I had. Okay. Oh, and here's the table if you were interested on kind of the best summary I saw of how to increase lifespan and things we often do aside from not eat, like reduce calories. And so smoking is by far the worst. If you can stop smoking, you can save up to 12 years compared to a heavy smoker. Physical activity, you can save 7 to 8 years. Healthy diet, 4 to 5 years. And then alcohol was the bottom at 2 to 3 years. All right, thanks everyone. Good luck with the rest of Foundations. That's my last synchronous. How do you differentiate reduction of calories versus an eating disorder? That's a good question. You'll have a clinician talk to you about eating disorders in year 2. So I'll leave that to them. I mean, I think that is it negatively impacting their physical health or mental health would be my guess. But right. I mean, you could have metrics of not BMI, but percent fat and stuff like that too. Can you run through the question on Angelman passing to the child, or do you want us just to wait for office hours? I'd prefer office hours because I want you to try to work through that. It's like a quiz question where you'll gain talking it through with a group, hopefully. Okay. All right. Bye, everyone.